Hello everyone, welcome to our channel 2bits. This is our second video on the linked list series, and in this video we will be discussing the Leetcode question middle of the linked list. So in this question we are given with the head of the linked list and we need to return the middle node of the linked list. Now we need to return the node and not just the value of the middle node. So for example, here we are given an odd length linked list and we need to return the middle node. So our first basic approach would be to calculate the length of the linked list. For example, here length is equals to 5. We divide the length by 2. We will get the flow value, which is 2, and then we increment it by 1. So we get 3. So we get the third node, which is the middle of our linked list. So how did we do that? First we traverse the whole list to calculate its length, which will be 5. As we are only given the head and we do not know the length, so we need to calculate the length by traversing the whole list. Then we traverse the list again to reach to the third node, which is the middle of the linked list. Now let's see the case of the even length linked list. So here first we need to traverse and calculate the length. So our length would be 6, then we divide it by 2, we get 3. And as the question says that if there are two middle nodes, then we need to return the right one. So we will increment by 1 and we get 4. So our fourth node will be the middle of the linked list. So first again we traverse the whole list to calculate the length, which was 6. Then we again traversed till the fourth node. This is the first node, this is the second node, third node, and then we reach to the fourth node to return this node. So what will be the time complexity of this particular solution? So first we traverse the complete list to calculate its length. So we traverse the complete list to calculate the length, then we traverse the list again till the middle node to return that node. So this will be the time complexity. Now we are not using any extra space, so the space complexity is constant. Now in an interview, firstly you will tell the solution and then you will tell the optimized solution. That's how you do in an interview. You first tell the basic solution, then you try to optimize the solution. So let's start with the optimized approach. Now in this approach we will take 2 pointers and point it to the head. So the first pointer will be slow pointer and the second pointer will be the fast pointer. So the slow pointer will be incremented by 1 and the fast pointer will be incremented by 2. And in the end, when the fast pointer reaches the end of the linked list, the slow pointer will always point to the middle of the linked list. Now let's see how that happens. So let's suppose that we have a slow pointer and fast pointer that is pointing to the head of the linked list, which is 1. Now we increment the fast pointer. Now we move the fast pointer by 2. So fast pointer reaches at 3 and we move the slow pointer by 1. So slow pointer reaches 2. Now in the next iteration we again move the fast pointer by 2, so it reaches 5, and we move the slow pointer by 1, so it reaches 3. As we see, we cannot move further. There is no other node and the next of this node is null, so we cannot move further. So this is the end of the linked list. So we need to stop our loop here, and we see that the slow pointer is pointing to 3, which is the middle of the linked list. So we simply return the slow pointer. In this solution, what we did was we took 2 pointers, slow and fast, and we pointed it to head. And we moved the slow pointer and the fast pointer till we reach the end of the linked list. So while fast.next not equals to null. So we see that when fast.next was null, we stopped here and we incremented the slow pointer by 1. Slow is equals to slow.next and the fast pointer by 2. So fast is equals to fast.next, that will increment it by 1, and again dot next, that will increment it by 2. And when this condition stopped, when the fast pointer reaches the end, we know that slow will always point to the middle of the linked list. So we'll simply return the slow pointer. Let's see if this solution works on the even length linked list or not. So again we take two pointers, slow pointer and fast pointer. Now the fast pointer will move forward by 2 and the slow pointer will move forward by 1 and reach the second node. Now in the next iteration again the fast pointer moves by 2 and reaches the node 5 and the slow pointers move by 1. Now again when the fast pointer moves by 2, it reaches null and the slow pointer moves by 1 and it reaches 4. So we cannot move forward as the fast pointer is null, and the slow pointer we can see that it is at the middle of the linked list, which is the fourth node. So we will simply return slow. So now we need to add one more condition here. We see that in this particular case we cannot move forward because fast.next is null. But in this case, the fast pointer itself is null. So we need to stop in this case as well, because we cannot find the next of null node. We cannot say null.next, right? It will give us an error. So we will add one more condition here if fast itself is not equals to null. And then we return the slow pointer. Let's see Python code for this particular solution. So this is the Python code for our solution. Firstly, what we did was we assigned two pointers, fast and slow, and made them point to head. So we have fast is equals to head and slow is equals to head. Next, what we did was we incremented slow by 1 and we incremented fast by 2. Until when did we do that? When fast not equals to null and fast dot next not equals to null. If any of these conditions arrive, we will stop our while loop. Until then, we need to increment slow by 1 and fast by 2. And in the end, when the fast pointer reaches the end of the linked list, we simply return the slow pointer as it will point to the middle of the linked list. So what will be the time complexity of this particular solution? We know that when the fast pointer reaches the end of the linked list, we need to stop the loop. So as our fast pointer is incremented twice each time, so it will only travel half of the node. So a time complexity for this particular solution is order of n by 2, which is approximately order of n only. So this will be the time complexity of this particular solution. Now the link for the C++ solution is given in the description, and the link to our Telegram channel is also given in the description. So please join our Telegram channel for important updates. Thank you for watching. If you like the video, then please share and subscribe to our channel as it motivates us to create more such content.